Hello class, welcome to Pre-Algebra Lesson 5.2, which is all about generating equivalent expressions. By the end of this lesson, you should be able to write equivalent expressions for the given expressions. So another way of thinking of equivalent expressions are so equivalent means equal, okay? And expressions, remember we talked about how expressions means there is no equal sign, right? Let me write two things on the screen for you. If I were to write 3 plus 0, and I would ask you, is that equivalent to the number 3? Most of you would say yes. If I were to say, let's see, what's another way of writing an expression that's equivalent to 3? So basically another way of writing 3. Well, if I were to write 3 times 1, that's also equal to 3, right? Another way to write 3 is I could say 5 minus 2. I could say 12 divided by 4. Okay, these are all different ways to write the number 3. Some of them are just not as straightforward as others, okay? But these are all considered equivalent expressions to each other. So let's talk about what does that look like in terms of our next lesson, right? Okay, so we have using these properties of operations. That's a fancy way of saying like using the stuff you know, using the laws of math that you know, okay? We want to use those properties to write equivalent expressions. Okay, so first, we have the student council has spent $300 on the supplies needed to sponsor a dance concert fundraiser. Given the cost of each ticket is $6, 3 council members write following expressions to represent the total amount raised for T tickets sold. Can they all be correct? Explain. So I don't know if you guys have ever had this happen where you're working with a friend and you write something down, your friend writes something down, then you guys look at each other's work and you think, what are you doing? That is not how you do it. First of all, there are many ways to do some of these things. So it is possible to have different work and end up at the same answer and have each other's work be, valid. So make sure you're respectful if you're working with others. But in this case, that's what we're doing today is we're trying to find multiple ways of doing the same thing. Okay. All right. We have the student council has spent $300. So usually when we're talking about spending money, we represent the money spent with a negative. Okay. So I know that if I were to write an expression to represent how much money was earned, I would use a negative 300 because we had to spend that. We didn't earn that. That's what we spent. Okay. And then the tickets that we're selling, they are $6 each. So that's how much money we're earning back, right? We're earning $6 for every ticket. So the way I would write this is I would say, okay, 6 times the number of tickets sold, that represents our positive amount of money. But then, we have to take that total and we have to subtract that $300 from it because that's how much we spent, right? So this is how I would write it. And you can see that is one of the ways. Okay. Now, another person here wrote it this way. They said 6 times the quantity of t minus 50. Well, what does that look like without parentheses? So before we even started our last chapter, I introduced the distributive property just in class to you guys. And we'll talk about it more in depth this chapter, but let's refresh. Remember, when you have these parentheses with a number right outside, it means that you're going to be multiplying. So I'd have 6 times that t. And another way to write multiplication is by not having a symbol in between, just smushing that number and letter together. And then I still have that minus sign, and 6 times 50, well, that's 300. So is this another way to write the same thing? Yes. So the first two are equivalent expressions, right? Now looking at this last one, this person put negative 300 plus 6t. And a lot of you guys do this where you take the first number listed, so in this case, that negative 300, and you list it first. Perfect. Just fine. That works. As long as our numbers have the same signs. And what I mean is if I look over here, this 300 is negative, right? And if I look over here, this 300 is negative. Perfect. If I look over here, this 6t is positive. If I look over here, this 6t is positive. So my signs match, the negatives and positives match, the numbers match, and the letters match. That means that this is also an equivalent expression. I just switched the order, or this person switched the order, and that's just fine, okay? So today is all about coming up with multiple ways to write another equivalent expression. And that's what I want you to do with this first question, okay? We have Nancy wrote the expression 3x minus 12 to represent the relationship in a table of values. Use properties of operations to write two equivalent expressions. Okay, so the first one we have is 3x minus 12. Now, why don't you go back to the first example and use this kind of as a template, okay, for some good ideas of how you could maybe come up with two equivalent expressions. Good luck. All right, for this problem, maybe you got these as two other equivalent expressions if you were following the pattern from the first example. For this center one, you factored. Maybe you remember that word. That's another thing I introduced to you along with that distributed property, where you take things out, right? You say, okay, well, what do 3 and 12 have in common? Well, they're both divisible by 3. So you put that 3 outside, and then you create parentheses, and then, well, 3x divided by 3, that's just going to be a 1x, or just x. And then 12 divided by 3 is 4. So you'd have minus 4 on the inside, because we had that minus, okay? So that's another possible answer. Another one is just switching the order and saying negative 12 plus 3x. And maybe you came up with something else, and if you want me to check what that is, feel free to show me in class, okay? I'm happy to check your work for you and talk through things if you have questions, okay? This is a great time for you to start asking questions and getting feedback. It's better to get feedback now than when you are taking your test and thinking, oh man, I wish I would have asked that earlier, okay? Now, example 2, writing equivalent expressions by combining like terms. And we'll dive deeper into combining like terms later this chapter as well, okay? But for now, let's practice writing equivalent expressions by combining like terms. We're going to deal with some pretty simplistic stuff right now. I see for this first one, I have negative 5x plus 2y plus 3x. And you'll see I underlined both of my x terms with the same color. And what I'm going to do is I just want to write those next to each other, right? We can change the order of things, right? If I were to say 3 plus 4, you would tell me that's the same thing as saying like 4 plus 3, right? That's something called the commutative property, where the order doesn't matter, that you're adding things, okay? All right, so I have negative 5x plus 3x, and when you're combining like terms, you keep your variable, and you just add your numbers like normal. So a negative 5 plus 3, well, that's a negative 2. Okay, so I have a negative 2x, and then I have this 2y, and there aren't any other y terms. So I'm just going to say that, okay, well, my 2y is going to stay a 2y. And then the last thing I can do is I'm going to write them together as an expression. I'm going to say negative 2x, and then it's a positive 2y, so I'm going to say plus 2y. And that would be my solution here, okay? Now, let's pretend for a moment that we have something slightly more complex, okay? So let's pretend that we have one added level of difficulty. So we have negative 5x plus 2y plus 3x, and then let's say we have a plus 9. Okay, so again, these things are all going to stay the same, right? Like the x's, I'm going to combine those. So negative 5x plus 3x, that's going to give me a negative 2x. and then I still have that 2y, so that's has nothing to change it. There are no other y terms, so it's going to stay a 2y. And then if I look, I have this positive 9. There's nothing to change with that positive 9, so it's going to stay a positive 9. And my last thing would be to write all of those together. So I'd say negative 2x, it was a positive 2y, and it was positive 9. Okay? Now, let's add one more level of difficulty, okay? I'm going to change this. All right. So I'm going to say, what if we had, let's say like a negative 4 out front here? Well, that negative 4 doesn't have a variable, so I can combine it with that positive 9. So that's going to be a positive 5. So then that one would change, but the rest of my answer would stay the same. So hopefully having those different colors helps your brain kind of see that pattern of what can you put together and what can't you put together. Okay, let's look at another problem like this, but this time involving fractions. If you have questions about that, please, please, please ask for some help. I am happy to help you. But let's look at this. We have 1/3 x plus the quantity of 1/6 x plus y. Now, that 1/3 x, that's outside of the parentheses, that matches with that 1/6 x, right? But it's a little weird because we have parentheses that are around the 1/6 x and the y. Since there isn't like a number that's right here or something that's multiplying with it, those parentheses honestly don't really mean a whole lot. What we can do is we could even move them without changing this expression. This would still be an equivalent expression. But now I'm using the parentheses to group the like terms, right? Both of my x terms are inside the parentheses. When you change where the parentheses are, that's called the associative property. It just means that you can group things together so that way you can combine them, okay? So I have 1/3 x plus 1/6 x. That means I can combine those. I need a common denominator before I can do that. So I know that I can change this 3 to be a 6, right? So I can change that by multiplying by 2. So 2/6 x plus 1/6 x. Now I have a common denominator. It's the only thing I've changed. And that would equal 3/6 x plus y. 3/6 x, if I simplify that, that's the same thing as saying 1/2 x. And then I still have that plus y. And now I have an x term and a y term. Since those letters do not match, I cannot combine them. I am going to leave them separate like that. Okay? Now, this is a problem for you to solve on your own, okay? So go ahead and combine your like terms. When you are writing your answer, something to know is, does the order really matter? And technically, no, but I'm going to tell you what the best practice is, that if you want to get into this habit now, it makes your life easier later, okay? So when you're writing these, you want to write them by alphabetical order. So, wow, order, not order. Alphabetical order. So meaning like A, then B, C, D, E, F, G. When we get to the end of the alphabet, it goes X, then Y, then Z. Okay, so you always write it alphabetical order, and then you do the regular number. So followed by what are called constants. And constants are your numbers without letters. And we call those letters variables. Okay, so your constants are numbers without variables. Okay, so go ahead and try to combine your like terms and type up your answer and see how you do. Good luck. All right, for this problem, hopefully you ended up with 9x plus 3y minus 8. If not, maybe check out my work over there on the left, ask some questions, whether myself or a friend, and make sure you get your questions answered. Excuse me. Let's move on to our last example for today. We want to be able to identify equivalent expressions. So let's say I give you a list of expressions and I want you to tell me which ones are equivalent to, in this case, negative 2/3 x minus 2. And then you would have to say yes or no, and you might have to tell me why, okay? So looking at this very first one, I have negative 2/3 x plus a negative 2. Is that equivalent? Is that the same as what was given up here? And I'm going to say yes, it is equivalent, because whenever we have a plus negative, that's the same as a minus, right? So I'm going to say that yes, that first one's equivalent. Now, let's look at the second one. I have 2 minus 2/3 x, okay? So I have that negative 2/3 x, that's perfect, but instead of having a minus 2, I have a positive 2. So I'm going to say no, not equivalent, because it's not a negative 2. Okay. Then let's move on to our last one. I have negative x plus 1/3 x plus a negative 2. So right off the bat, I know that this right here, that's the same as saying minus 2, right? And I have negative x plus 1/3 x. So if I think about this, this is a negative 1x plus 1/3 x minus 2. I know that negative 2 checks out, right? But what's negative 1 plus 1/3? Well, negative 1, another way to write it, negative 3/3. And then plus 1/3, that's going to be a negative 2/3 x minus 2. So that does match. So I would say yes, this is equivalent to that expression. Okay. Then right here you will have a key concept page, so you can see a couple of those properties listed. You can see an example. If you have any questions about this lesson or just anything in general with this, please be sure to reach out for some help. I'm happy to help you. Have a great day.